Hi everyone, welcome back to another Pre-Calculus 12 video. Today we're moving on to trigonometry, and I'm going to go through the first little bit from angles and their measures, 6.1. And I'm going to start off with some review, and you'll notice I'm so excited about this. I learned how to change the page to black. And I'm going to switch it up today. It's kind of fun to switch things up, and so we'll see how this goes. It's the first time I'm doing this. But I think it would be nice to start off with some basic review from things that you already know from last year, but you've probably forgotten. So I think it's nice to start with review. So just a reminder, when we're taking a look at our quadrant here, you know that this would be the x-axis, this would be our y-axis, and then just a reminder that we go in this counterclockwise direction. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so I feel like this you already pretty much know. The other thing about this is you may remember this, all students take calculus, and basically what we use that for is to determine, where, or I should say which angles, which trig ratios are positive in which quadrant. So just to quickly brush up, for example, all in the first quadrant means like sine, cosine, and tangent. They would all be positive in quadrant 1. When we move to quadrant 2 over here, only sine would be positive. So remember, sine is opposite over hypotenuse. So remember that SOHCAHTOA. I'm going to write that here. SOHCAHTOA. So this part is referring to sine is opposite over hypotenuse. This is cosine is adjacent over hypotenuse. And this is tangent is opposite over adjacent. So I've given you a bit of a worksheet to review or brush up on that before starting the new stuff, so hopefully you're all caught up and have already done that. But that's basically a quick review. I'll also just briefly show you that this naturally leads to the unit circle, so I'm going to redraw that. Oh boy, you know that my circles aren't perfect, but good enough. So if this is our unit circle, we always go, well, basically, if we were to, this is like where we would start things off, and we go in a counterclockwise direction. So if I go all the way around, we all know that this would be 360 degrees. That would be a full rotation. We're familiar with and so used to using degrees, so that's what I'm going to start off with, and then eventually I will teach you about another unit of measurement for angles, which is called radians. So that'll come up later. And then let's break this down a bit. If I just go from, well, maybe I'll use my favorite color, purple. If I go from here to here, we know that that is 90 degrees. If I keep going from there to there, well, actually it would be from the start to there, but that would be a full 180 degrees. And if from there I keep going and I go down to here, that would be 270 degrees, and then we already talked about how if we went all the way around, it would be 360. So, quick review of our unit circle. We also have this formula, x squared plus y squared equals 1, and I'm going to put this here. 1 is the radius of our unit circle. So because it's the unit circle, we are choosing to make it 1, but we will get some examples and some scenarios where it won't be a value of 1, but we can work with our ratios and proportions to use the formula and change it and manipulate it accordingly. Okay, so if I were to draw, and maybe I'll draw it on here in yellow to show you, but if I go from the origin, my point here where it's 0, 0, to some other point here, I'm going to just call that point X, Y, and maybe I'll call it point P. This yellow arm that I just drew, just a reminder from last year, this would be called our terminal arm. And the terminal arm, like I just randomly drew it, but it looks like it's kind of halfway in between 0 and 90 degrees. So I could say this is at roughly 40 degrees or so, 45 or 40, doesn't matter. So let's say that you know that that terminal arm that we had there, I'm going to say that it is 40 degrees. Well, I could find a co-terminal arm. Let me write that down here. Co-terminal. What I would do to find a co-terminal angle is I would go to my 40 degrees, and from there I would rotate another 360 degrees. So in order to make this clear, I'd take my original 40 degrees, and then I would add to it 360 degrees. So that would give me a full rotation to get to that 40 degrees again, and I would see that my new co-terminal angle, and that's, we know that from before, that's our symbol for angle, and that would be 400 degrees. So basically, 40 degrees and 400 degrees fall on the same arm. So another thing that I want to show you is that I also could go the other way. So I'm going to get rid of this blue, and I'm going to show you the co-terminal negative angle. If I'm starting again at 40 degrees here, and I want to get my angle that is, so I start again at that 40 degrees, but this time instead of going counterclockwise, which is a positive direction, I would go, oh, I should do that in purple so you can see what's happening. I would go in the opposite direction, all the way this way. So I would actually do 40 degrees minus my 360 degrees. And so my new co-terminal angle would be negative, that's not a 3, negative 300, oh, I wrote negative twice, negative 320 degrees. So again, to be clear, 40 degrees, 400 degrees, and negative 320 degrees would all fall on the same terminal arm. Those are all called co-terminal angles. So they technically would end up being the same value if we unraveled it and got to the smallest value between the starting point and our terminal arm. Okay, so this 40 degrees that we keep referring back to, so see this 40 degrees and it's in the circle or the diagram there. I'm going to write that down here. That 40 degrees in this case would be our standard angle. I'm going to use the symbol instead of taking the time to write out angle. So that is the angle between the positive x-axis and the terminal arm. That is called the standard angle. So in this diagram, I'm kind of coloring it in here, it would be this 40 degrees here. It's from the positive x-axis up to the terminal arm. So even though 400 degrees and negative 320 degrees are technically the same angle, or they're coterminal to 40 degrees, it's the 40 degrees that is like, so how I always use this as a theme, I like to look at, like, take everything back to its basics and strip it down to its most basic form. I guess you could look at the 40 degrees or the standard angle as being an angle in its most basic form. Okay, so I hope that that is good so far and is making sense. And then just to practice a few examples before we finish this off, let's take a look at, if we have, I'll draw it right in the center here, so I'll just say this is an example. If we have our unit circle like this, and on here, let's say the first one, well, first of all, let me start by saying this. We've been working with lots of polynomials, algebra, all sorts of things, where we usually call an unknown x. We could call it any variable. I could call it y, I could say it's m, but in the case of trigonometry, as you know from before, we would use this symbol, theta, to represent an unknown angle. So this would be our unknown angle. And so let's say, for example, we want a label where theta is 120 degrees. And all I want you to do is to become familiar with the unit circle and where things fall and fit in on the unit circle. So that's why I started off by mentioning how this is always going to be our starting point. And then we go in a counterclockwise direction. So we're headed in that direction. We know again that this would be 90, this would be 180, this would be 270, and this could be 0, our starting point, and or it's also 360, because you could say those are coterminal, if you think about it. So if we are trying to label approximately where 120 degrees would fall, well, first of all, I want you to think which quadrant would 120 degrees be in. And we can tell by looking at it, it's got to be between this 90 and this 180. So it would be in quadrant 2. So I'm going to say that here. It would be in quadrant 2. And if it's 120, we're going to approximate and say maybe it's around there. So we would draw it going this way, and that would be our 120 degrees from the starting point all the way over to there. And we would go counterclockwise to get there because it was a positive angle. So let's say now I give you another example. We'll do it on the same unit circle so that you can compare and contrast them. But let's say this time I want negative 100 degrees. So the first thing I want you to think of, and again, you can pause the video at this point to check, but where or which quadrant would negative 100 degrees be in? So maybe since we're new at this, to think our way through this, we still go back to our starting point, but now I'm going to go in this direction. So down here would be negative 90, up here would be negative 180, and up here would be negative 270. So I want to make sure that you understand that switch and how to shift the way that you're looking at things, shift your perspective a little bit. So if we're going to negative 100, we can see it must be in quadrant, remember it's 1, 2, 3, so it's going to fall in quadrant 3, because I know if I head downwards to negative 90 in a clockwise direction, well, negative 100 is going to be just slightly past that. So I could say it's maybe around here, starting from here to here. I could say, look at that, this would be my negative 100 degrees that I was looking at. And I would go in a clockwise direction to get there. Okay, so maybe just to be really comfortable with this, let's take a look at theta. So this time our angle is, let's say, 380 degrees. I want you to think of, I would say pause the video, do this yourself, then when you're ready, hit play again so you can see the solution and check in to see. If you just sit there and watch it passively, it's a lot harder to see if you've actually understood it. So that's my suggestion. 380 degrees, we want to think of which quadrant that's going to fall in. So we know this time we're going in a counterclockwise direction, and I know if I did a full rotation this way, I would end up at 360 degrees, but this is telling me 380 degrees. So I'd probably be around right there. So I'm going to write there. If I go all the way around, that would be 380 degrees if I go all the way around to there. I'm going to get rid of that one. I'm making a big mess out of this, I get that. So we can see that we would be in quadrant 1. And we're going in a counterclockwise direction because it was positive. Okay, maybe we'll do one last one before we stop here. I'm running out of room, so I'm going to do it up here. Let's say I wanted theta equals negative 400. I want you to think of where that's going to fall. Negative 400 degrees. Same questions as before. Try to see which quadrant that's going to be in, and then which direction we're going to go in. Let's think of that. So again, pause the video if you like, give this a try, and let's think our way through this. So this time, let me get rid of some of this stuff so that we can actually see and make sense of what's happening. So let me get rid of all of that, and let's kind of start with a clean slate. So if we are wanting to go to negative 400, well, let's talk our way through this. One full rotation this way would be negative 360 degrees. I want negative 400 degrees. So I can see that I would go, let's say, a little bit further, almost to the halfway mark. So that's probably a good spot for me to end up at. That would be my negative 400 degrees. So I end up in quadrant 4. Okay, one more quick little bit of review, and that is our angles. And this is going back many, many years, but it's always good to have a bit of review and to brush up. So if we have an angle like this, if it's between 0 and 90, we call it acute, and it's just what it sounds like, a cute little angle. So it's between 0, so it's bigger than 0 degrees, but it's going to be less than 90 degrees. That's technically an acute angle. And then if we get to an obtuse angle, I should draw it better. If we get to an obtuse angle, that's going to be between 90 degrees and 180 degrees. So let's say we have something there. That would be an example of our obtuse angle if our theta goes from the starting point all the way to that terminal arm. And this one I know you all know. A right angle, just to remind you, is if it's right at 90 degrees, that little box always indicates, but that's a right angle, and we know that that would be 90 degrees, which is also a quarter of a rotation. You're going to find in your book that sometimes they refer to the fraction of the rotation of the circle. So it's a good thing to look at it this way and just to sort of brush up on that. And then the very last one is a straight angle. Straight angle is exactly what it sounds like. So if we go all the way to 180 degrees, that's an example of a straight angle. And again, if we want to think of it in terms of like what we just used in the last one, so straight angle, that would be a half a rotation. So it's good to think in terms of fractions when we're dealing with our trigonometry. I hope that was helpful. You are going to do page 255, so this is the first half of 6.1, and I'm going to have you do 1, 2, and 4, the odd letters, and if you're wondering what that is, a reminder, that's like A, C, E, etc., etc. Okay, I hope you found that helpful.